Hey everybody, welcome back. Everyone's favorite spot, virtual geometry here in KO8. Mr. Crofton coming at you with another lovely concept that we're going to go over, get a little practice and a little work on. So today what we're doing is flowchart proofs for congruence. So it's a pretty cool, but definitely a different concept that you definitely haven't seen in previous math classes. So the first question might be, okay, what's a flowchart? Here's my example of one. And of course, we're using a little geometry because, well, why not? We're in geometry. So this example here, I've got two bubbles basically, right? And statements in each bubble, okay? My first statement is all squares are also rectangles. My other is ABCD is a square. These two pieces of information come together and can tell me a third thing. That third thing is that A, B, C, D is a, well, I know that all squares are rectangles, and I know ABCD is a square, therefore ABCD is a rectangle. Okay. So this is an example of a flowchart. One thing I really want to point out that's very important that gets overlooked sometimes are the arrows, okay? It's very important that this fact here and this fact here together lead to the fact that ABCD is a rectangle. Without either pieces of these information, without knowing ABCD is a square, I can't say it's a rectangle. Without knowing that all squares are rectangles, I can't say that square is a rectangle. So both pieces of information are important coming together, telling us that ABCD is rectangle. Yep. Now the proofs we're going to be doing, there's also going to be reasons here where I'm drawing lines, but that's something we'll get into right now. Okay. Here's my proof. Now it's a proof of triangle congruence. So my end goal is to prove that these two triangles are congruent. The one thing I always say, now these proofs are always a handful of points, right? Get those free, easy points, all right? 99.9% of the time, your proof will start with something that's given. So go ahead. As long as you can read the shape, read the markings and what they represent, you should be good to get a lot of points for free, right? So the first thing I see, angle D and angle G are equal to each other because they're marked like that. So my first bubble is going to be angle D is congruent to angle G, and my reason underneath it is given. Again, given just means it's drawn in the diagram. I know it. I can see it right there in plain view in front of me. Next thing I see, more free points sitting there. Boom, boom. Those two sides are equal. So, well, congruent, I should say. DR is congruent to segment GR. And the ordering of those letters is kind of up to you. Not a big deal. That reason's also given. Awesome. I got a lot of stuff just from reading the diagram. Now I've got to go a step further, though. Okay. From just straight up geometry 101, I see what's happening here in the middle. There are two what are called vertical angles. Now, common mistake here, a lot of people go and say, all right, well, angle R equals angle R. Angle R is what? I don't know. It could be up here. It could be down here. It could be any of four angles at point R. So don't use that here because there's multiple angles there. To name these angles, I want to name them by tracing them. ERD is congruent to angle, I'll call it ARD. And my reason is that they're vertical angles. Okay. So you might be thinking, hey, wait a second, you just named them right here, D and G, but that's because, hey, there's only one angle there. There's only one angle there. I'm safe to do that. Um, for you who are kind of unsure when to do three letters, when to do one, do three all the time. You know, it's always safe. It's never going to be wrong because of that. All right, now I've got a pair of angles, then a side, then another pair of angles. I've got enough to prove congruence. Boom, boom, boom. These three facts come together to tell me that triangle, now be careful and name them in the right order. I'll name it DRE is congruent to triangle. Let's see. I went from D to R to E. I want to go from this angle to the side, to the other angle, then to the last one. So do it the same way. GRA. Lastly, the reason is angle, side, angle, congruence, shortcut. That's like from the previous video we looked at determining that. Awesome. All right, one down. Let's check out another one. All right, this one. Now, let's see. What do I start with? Easy given points, right? So go back to that and get the free points. I see this and this are marked with a single, therefore they're equal to each other. Now I'm going to say Fn is congruent to Mu. And naming segments in whatever order, that's generally accepted. Either way is fine. Fn and Nf are the same. Given. Good. Another statement. This double and this double. Another given one here. So Nm is congruent to, how about Uf? Also given. Okay, I got two pairs of sides that are congruent. I need something else because SS is not a shortcut. But you notice right here in the middle, both sides share that one in the middle, NU or UN, however you want to name it. So my next statement here is NU is congruent to UN. And again, the order of the letters is all well and good, doesn't really matter. NU and UN are congruent. My reason for that, you could say it's like a shared side, but my formal good geometric word is alright, it's getting pretty low there, but that is the reflexive property. Reflexive property. And the reflexive property states that something is equal to itself, basically. It's a pretty obvious, easy one given to you. Something equals itself, NU, UN, same thing, equal to itself. Okay? Now, I've got 1, 2, 3 sides. All right, I've got enough information. 1, 2, 3 sides. So I'm going to state that triangle. Now, I got to be careful here with order. First one I can name anyway. So, how about FUN? So I went from F to U to N. Okay. So notice I went across the side mark twice, then the side mark 3 times. I want to do the same thing. Okay. I started all the way out here. I want to start all the way out here. M. Go again across. The side mark twice, and then the side mark 3 times. So M N U. And that's my side congruence. Cool. All right. 2 proofs down. We're going to do one more together, and then I'll give you one to do on your own. But before we do that, there's been a huge breakthrough in the field of mathematics. I finally discovered it, guys. I'm really excited to announce it. I found a square root. Isn't that impressive? I've been looking for, I'm going to say, years, but I finally found a square root. And, you know, that's all well and good, but I realized how silly I was the whole time. Where's the number one place to look and find a square root? Obviously, the geometry, the famous geometry. Well, either way, you know, live and learn, but we finally found the square root, and it's under the geometry. All right, let's continue with this last one. All right, start the same way we've started every one so far. State those givens. I see this angle and this angle are equal. So I'm going to say angle S, because again, there's only one angle there, is congruent to angle N, and it's given. Awesome. Next thing I see, all right, nothing else marked here, but wait a second, I got these arrows. Arrows mean parallel sides. So I'm going to state now that SA is parallel to MN. Very important to note, that is not saying those two sides are equal. It is not saying they're equal or congruent. It's just saying that they're parallel, which will lead to something else. So, now let's see, what else do I have? Well, let's stick with those parallel lines. Now, that's going to lead to something. Again, this and this are my 2 parallel lines. What I tell my students often is to look for a Z. look to be able to make that Z with two parallel lines. And I see right here is my transversal that creates, I'll mark it with 2, alternate interior angles. So it's very important. This fact leads to the fact that angle, and notice, at point M, there's multiple angles. So I'm going to name this angle NMA. That's this angle up here. Is congruent to angle, let's see, NMA congruent to SAM. And that's because they are alternate interior angles. Good. Or AIA for short. All right. Now, I've got one pair of angles, two pair of angles. It's enough to prove similarity, but I don't want to prove similarity. I want to prove congruence. So I got to look for another trick here, and I see it right in the middle. I got another shared side. So let's state that. I can put these bubbles anywhere, notice, because of the arrows. I can kind of organize my thinking in any way I really want to. That's why you see some people go from up to down or left to right, whatever. So I'm going to say MA is congruent to MA. I could have named it AM, whatever. That is, again, my reflexive property. Okay. I've got now an angle, a side, and another angle out there. Okay. So, one pair of angles, two pair of angles. I'm sorry. One pair of angles, one side, and another pair of angles. Let's put it together. Triangle, let's name it SAM, congruent to triangle, SAM, NMA. By what shortcut? Notice I said a lot of two angles on one side, but guess what? The side is not between the two angles. So my shortcut here is side angle, angle congruence. Okay. You also could have written angle, angle, side, as they are the same exact thing. All right, guys. That's going to do it for us here in K08. Signing off. As always, I'll give you one to try out on your own and come in with this completed, see how you did. Remember, start with the givens, get the free points. All right? Hope this helped out. I'll see you guys soon.